Okay. So the mass of the beaker is 50 grams. Okay. And it says that a liquid of density 1.8 gram. So density is equals to 1.8 gram per centimeter cube reaches the 200 centimeter mark. Okay. Okay. So that means the volume is equals to 200 centimeter cube. Now the question was calculate the total mass of the beaker and its contents. Okay. So we've got to figure out the mass of the liquid. Now density of the liquid is basically going to equal to mass of the liquid over the volume of the liquid, right? So we've already been given the density, which is equals to 1.8 gram. What is the mass? We don't know. What is the volume of the liquid? That was 200 centimeter cube. So that just means 200 into 1.8 is going to be the mass of the liquid. So what does that turn out to? That turns out to 200 into 1.8, which is equals to 360 gram is just for the fluid. And then the beaker was weighing 50 grams as well, right? So that means 360 plus 450, 410 grams is the mass of the fluid. Okay. The center of mass of a meter rule is at the 50 centimeter mark. Okay. Right? Because a meter rule is basically exactly equal to 1 meter or 100 centimeters. State what is meant by the center of mass. Now, the center of mass basically means the point at which all the weight can be assumed to act. The point at which all the weight can be assumed to be acting, right? Okay. So it's kind of like it is this center at which all the forces are balanced and it can be assumed to stay stationary and all of the weight can be assumed to be acting at this certain point. Okay. Although all of the different, for example, if you have a cube, okay, every single particle is going to have its own weight, right? So you have multiple particles. All those single particles are going to have their own weight, right? They're going to have certain W, tiny w, tiny w, tiny w. So every single particle has its own weight. But if you take an average behavior, the average can be assumed that all of the forces add up at the center, which is equals to the large W, which is the center of mass. So all of those tiny particles add up to the weight, and that can be assumed to be acting at the center of the mass. Okay. Now, the meter rule is placed on a pivot. Okay, so this is the meter rule. The tip of the pivot, okay, we don't need to read that. Okay, the question is calculate the mass of the rule. Okay, now we've got to figure out what this is, right? What is the mass of this entire ruler? Now, notice two things. You have a pivot over here, okay, and you have a beaker over here, okay. Now, this is the center of the mass of the rule. That means all of the weight of the rule can be assumed to be acting at this point W, right? And if this is the pivot, okay, then you only have two forces, right? On the pivot, you have one force which is of the ruler, right? Because the ruler's weight is going to make the ruler turn in this direction. It's going to be anti-clockwise, right? But you've got a beaker that is balancing it, right? The beaker has a center of mass in the center as well, right? It's going to have a weight equal to, let's just call it F. And the beaker is going to turn your ruler clockwise, right? So that must mean if the ruler is in equilibrium, right? If it's balanced or it's in equilibrium, that must mean that the weight of the beaker should equal to, sorry, the moment due to the beaker should equal to the moment due to the ruler. Now, how do you figure that out? Again, sum of clockwise moment is equals to sum of anti-clockwise moment. Okay. Now, what is anti-clockwise moment? That's just equal to weight times distance from the pivot. What is this distance? So if this is the 50 centimeter mark, this is the 80 centimeter mark, then this is actually going to be 30 meters, 30 centimeters, right? Keep in mind, always write down units in centimeters, sorry, in meters, right? So 30 centimeters is just 0.3 meter. Okay. Now, do we have any other clockwise moment? Yes, we do. The force due to the beaker, right? Now, this should be F times what distance? How do we know what is the force now? First of all, what is the distance till the pivot? Be very careful of it. Now, they've given us 2 points. They've given us this is 84 centimeters, this is 92 centimeters. Okay, now what do I do? Is it going to be 4 centimeter? or is it going to be 12 centimeter? Now, the beaker is also uniform. Okay, they've stated that in the question. If the beaker is also uniform, then that must mean that all of the weight should be acting at its center, right? Then that means that the force, you're going to take the force as if it was acting exactly at the center. So that would mean this distance, right? This is 4 centimeters. And what is the extra distance till the force? You can check it out. So how do we know that? So what you would do is, how do you figure out what is the center of 84 centimeter and 92 centimeter? Now, how do you figure that out? If the beaker has a base of what? So if this is 84 centimeter and this is 92 centimeters, then that must mean that the length of the beaker, right, from bottom is actually 8 centimeter. 8 centimeter, 8, 4, yep, 8 centimeter. So that the base has a length of 8 centimeters. Then that must mean half of it would be 4 centimeter, right? So 4 centimeter and 4 centimeter. So that means the distance from the pivot is going to be 4 centimeter till the edge and then 4 centimeter till the center. So that's why you're going to take the length of the force from here to here. It's going to be a total of 8 centimeters. Okay, so be careful about that. So it's going to be F into 0.08. Why? Because 8 centimeter divided by 1000 is 0.08. Now, what is the force F? What is the weight of the beaker and its contents? You figured that out in the previous question. You knew that the mass of the beaker is 410 grams, including the contents. But what is its weight? Keep in mind, you don't take the mass, you take the weight, right? So be careful. So, weight. So what is weight? Weight is equals to mg, right? So 410, not 410, but mass is always in kg. So 0.410. Okay, so 0.410 times g is going to be the weight of the beaker. Oh, sorry, the weight of the beaker, right? So that's going to be, instead of W, I'm going to write 0.410 into G. 410 into 9.81. Okay. And then, okay. So when I do that, I will get F, right? So let's check what F turns out to. Oh, wait, but we'll have to convert it back into mass. Okay, okay. But let's just do it anyways. Let's just do the extra step. 0.410 into 9.81 into 0.3 divided by 0.08. Okay, so that means F is equals to 15.08 newtons. This is the weight of the mass, but the weight of the ruler. But what is the mass of the ruler? You again divided by 9.81. If you again divided by 9.81, then it's going to be 1.53, 1.53 kg. Yep. Yep. So this is the mass of the ruler, right? Because weight is equals to mg and m is equals to w over g. You figure out the weight of the ruler and you divide it by 9.81 and you have clearly got what the mass of the ruler is. Okay. Any questions? No? Okay. Moving on. Now, next question. This is a tricky one. Okay. It's from May June 17. A cylinder is made from a material of density 2.7 gram per centimeter cube. Density is always equals to mass per unit volume, right? So density, they've told us it is 2.7 gram per centimeter cube, right? That's what the number means. It means that for every 1 centimeter cube, the mass is equals to 2.7 grams, right? So for example, if you take out a 1 centimeter cube chunk, right, then that 1 centimeter cube chunk is going to have a mass of 2.7 grams. That's basically what the idea of density is. How much mass do you have packed into a single, unit of volume? Okay. The cylinder has a diameter of 2.4 centimeters and a length of 5 centimeters. Show that the cylinder has a weight of 0.6 newtons. Okay. Now, try to think about what you even need to do to figure this out. Okay. First of all, it seems absolutely clueless. How do you like even prove this in 3 marks? And where should I even start? You've been given absolutely random values. Now, always try to picture what has been given to you. You have been given that a cylinder is made from a material, a cylinder, okay? And the cylinder has a diameter of 2.4 centimeters, okay? This is D. And it says that it has a length of 5 centimeters, right? Okay. Show that the cylinder has a weight of 0.6 newtons. That seems absolutely random. How do you even like get to weight from these two values? Now, the key is in the word of density. Now, we know that density is equals to mass over volume, right? And we know that weight is equals to mg, right? So what if I found out the mass first? We know that the mass is just equal to density times volume, right? And then if we find out the mass, can we just divide, if can we just multiply it by g to find out the value? Yes, we can. So I think the goal is just to find out what the density is. Okay. Sorry, what the mass of the, cylinder is. First of all, keep in mind that the units of density over here are 2.7 gram per centimeter cube. Okay. Per centimeter cube. Okay. Okay. So because the units are in centimeter cube and the value of density is also in centimeter cube, so you don't need to convert it into meter cube at the moment. Okay. But keep in mind, because the units of density was gram per centimeter cube, the mass that you're going to get out is actually going to be in grams. Why? Because you didn't convert this. You could convert this into kilograms and then you would get your answer in kilograms as well. Okay. But let's just not do that. We don't need to make our working a bit more complicated. Okay. Now the density is 2.7 gram per centimeter cube and multiplied by the volume. Now, how do you figure out the volume of a cylinder? That's something you have to learn. The volume of a cylinder is equals to the area multiplied by the length. The area multiplied by the length. What is the area of a circle? It's pi r squared, right? And if you multiply pi r squared to the length, that's going to equal to the volume of a cylinder, right? So this is the area, and if you multiply the area a lot of times, then that's basically what volume is, right? So volume is just equals to area multiplied by the length, and you already know what the area of a circle is, and if you multiply that with the length, then that's going to give you the volume of a cylinder. Now, what is the area? 2.4 is not going to be, it's equal to pi r squared, right? Into L. Now, pi into r is actually half the diameter, right? So r is actually going to be this value. This is r, right? So if d is 2.4, then r is going to be 1.2. So 1.2 squared into length. What is the length? It's equals to 5. Now let's check what this is. It's going to be pi into 1.2 square into 5. So this comes out as 22.62. Keep in mind, the units are going to be centimeter cube. Why? Because I did not convert the centimeters into meters. Okay. Now, so the volume is 22.62 centimeter cube. That means I can plug this in over here. 22.62. Let's check. Multiplied by 2.7. This gives me a mass of 61.07 grams. Keep in mind, because the units of density were in grams. If I wanted it in kg, then I would have to convert it from over here. Okay. So the mass is 61.07 grams. Then you can divide it by 1,000 to get it into kg, right? So now it's easier to convert it. So this is going to be 0.061. Where did it go? Okay, yes. Now I can multiply 0.061 into 9.81. And when I multiply that by 9.81, hopefully I'll get the answer, which is 0.6 Newton. And hence proven that it has a weight of 0.6 newtons, right? So you just have to be smart about the formula and connect the ideas. Okay. So
Sir,
this,
could you just
yes.
explain the
Hmm.
volume thing again? how you found the volume of the cylinder?
Hmm. For example, if you want to find out the volume of any cylinder, you have to remember that the volume of a cylinder is equals to pi r square times L. Okay, so you've got to memorize two formulas for the volume of a cylinder. Okay, so the volume of a cylinder is pi r square L, and the volume of a sphere as well. That's very, very common, which is equals to 4 over 3 pi r cube. So you sadly have to remember these because a lot of the shapes that we take in physics are either a cylinder, either a sphere, or yep, that's pretty much it. So that's why we use a lot of these volumes. We use that in
Okay.
wires as well. We use that in
Yeah.
area as well. Okay. Okay. Hmm. So I just use the formula pi r square into L. So this is pi r square times the length. So volume of the cylinder is going to be pi times r square times L, right? So we already knew what the radius was. The radius was 1.2 squared. What was the length? That was also given 5. So when I multiply this value, I'm going to get the volume. Okay. Yes, makes
Yeah.
sense? No? Okay. Okay. So it's just smart to, memorize the formula of the volume of a cylinder. In fact, I'll write that down. So which areas do you need to remember? For area, basic, so area you need to remember, basic, rectangles, triangles. Uh, what else? One second, let me write it down. So rectangle, triangle, circle, very important. Other than that, basically that's it. Is what else? What else? Triangle, circle, and yep, that's it. And then volume. We use volume more than area. Volume, the first and most important one is a cylinder. That's the one that is most often used. Sphere is also very commonly used, and cube, and what else? Yep, that's it. So, make sure you memorize the volumes and areas for it. There are shortcuts to this, but that'll take up too much time. So it's just better if you memorize it. Okay. The cylinder in A, okay, the cylinder in A is hung from NA of a non-uniform bar. This is extremely important information. Why? Because that means that not all of its weight is assumed to be acting at the center. Okay, so that's extremely important information. The bar has a length of 50 centimeters total and has a weight of 0.25 Newton. Okay. The center of gravity of the bar is 20 centimeters from B. So that means center of gravity of the bar is 20 centimeters. Okay. So this is the center of the gravity. This is the center of the gravity of the bar. And because he literally put the pivot over there. No, wait. 20 centimeters. Okay, okay, okay. So it's over here. Okay. So this is the center of the gravity, right? So that means it's not at the center where it's supposed to be, but it's slightly off. Okay. The pivot is 12 centimeters from B. Okay. We've given all this information of the object X. Okay. This was the cylinder that we just proved over in the first part. The weight of X is adjusted. The weight of X is adjusted until the bar is horizontal. Okay. So basically what they're doing is that this has a variable weight. Okay. And they keep changing this weight until this entire system is balanced out. Because what forces are acting? From the pivot, right? If this is the pivot, then that must mean that the rod is going to be turned anti-clockwise because of both of these forces, right? Because of this weight of the bar and the cylinder. But you can counter that moment by adding a weight X on the right side, which is going to counter it with clockwise moment. Okay. But we adjust that variable weight so that we can balance it out. Because if this is too less, then it'll fall this way. And if this is too high, then it'll fall this way. Okay. Now, explain what's meant by center of gravity. We've done that. Calculate the weight of X. Now, how do we figure out what this weight of X is? It's pretty simple. Now, always write down sum of clockwise moment is equals to sum of anti-clockwise moment first. Now, let's check out what are the anti-clockwise moments. You have the cylinder, and how far is it from P? This is going to be what? Let's check it out. So, okay, wait. Hmm. So if this is 50 and this is 20, then that means 50 minus 20 should be 30, right? So this is 30 centimeters. This is 30 centimeters. But this is still the center of gravity, not till the pivot. Now, what is this distance? Now, let's check it out. If this is 20 and this is 12, this is supposed to be 8. This is supposed to be 8 centimeters, right? Because 8 plus 12 is 20 again. So that means 30 plus 8 centimeters is the distance till the pivot. So that means 0.6 newtons multiplied by 30 plus 8. So 38. So 0.38 meters. Careful, always write it down in meters. Plus, now what is the force of the, okay, 0.25 newtons multiplied by, hmm, okay, so that's just 8 centimeters. So that's just going to be 0.08 multiplied by 0.08 meters. Okay, so these are all the clockwise moments. Sorry, these are all the anti-clockwise moment. Okay, that's fine. Anti-clockwise and clockwise. Okay. Then what is the only clockwise moment we have? Just this one, right? So this is just variable x into what is the distance from the pivot? That's just 12. So pretty easy. 12, not 12, 0.12 meters. Okay, so let's just calculate what this is. 0.6 into 0.38 plus 0.25 into 0.08 divide by 0.12. So 2.07 Newton. Yep, that's it. Pretty easy. Fairly basic question. Okay, now these were relatively easy questions to, give you a feel of how the easy question in moments are. But not all of the questions are this way. A lot of the questions are much more difficult, where figuring out the distances is much, much, much more difficult. Okay, in these questions, it was the distances and the calculation of centimeters and center of gravity, that was the only difficult part over here, and deriving this. But questions are going to be much more harder. These were the easy ones. Okay, now I've shown you what the easy ones are. Now we're going to jump to the slightly difficult ones. Now let's check it out. A lot of the questions are combined with other chapters, so that's why we're just going to do the moment part for now. Okay, so state what is meant by the center of gravity of an object. Let's make this bright. Oh, my eyes. Okay, state what is meant by the center of gravity. The point at which all the forces can be assumed to be acting, or all of the weight of an object can be assumed to be acting. Now let's read it out. Two blocks are on a horizontal beam that is pivoted at its center of gravity. Okay. A large block of weight 54 Newton is a distance of 0.45 meters from the pivot. A small block of weight 2.4 Newtons distance. Okay, so 0.95. And the right hand of the beam is connected to the ground by a string. Okay. So that means it's connected to the ground by a string over here. Okay. Okay. The beam is in equilibrium. So that means sum of clockwise moment is equals to sum of anti-clockwise moment, and it also means that F net is equals to 0. Resultant forces are 0. Now, by taking moments about the pivot, calculate tension T in the string. Okay, nice question. So, by taking moment about the pivot. So first of all, again, sum of clockwise moment should equals to sum of anti-clockwise moment. First of all, let's check what are the clockwise moments. This is going to turn you clockwise. So this is clockwise moment, and this is anti-clockwise moment. It's going to turn the rod in the other way. Now, what about the string? Now, imagine if there was no string. If it requires the string to keep you held in place, right? Then if you remove the string, think about it. This bar would then tilt like this, right? Because you need the string to hook you to the ground. If you remove the string, then the bar is probably going to turn like this. It's going to turn in this direction, right? So the string is actually providing, the string is actually providing a clockwise moment, right? it's going to provide an clockwise moment, because it is because of the string that you are held towards the ground. If you remove the string, then the anti-clockwise moment is going to be too much and your bar is going to turn anti-clockwise, right? But if you want to bring it back down, then you will use the string to turn you back down. Okay. So that means the string is providing an clockwise moment. So this is at an angle. And keep in mind, moment always requires that the force into distance are perpendicular, right? So if you were to do m is equals to f multiplied by d, if you take this as the distance, then the force you take should be exactly perpendicular to it. Can you figure out the perpendicular component of the string? Yes, we can. So you can break this apart into two components. So if this is t, wait, so yep. So this is going to be t cos 30, right? Then in front of the angle, it's going to be t sine 30, right? Can I bring this over here? I absolutely can, right? So this is going to be t sine 30. Okay. Now that means when I use the formula moment is equals to force into distance, I'm going to take this tension, not the horizontal one, because it is parallel to the distance. Okay. Now, clockwise moments, let's write down clockwise moments. So t sine 30 multiplied by 0.95 plus 0.35. Yep. 0.95 plus 0.35. Okay. Plus any other one? Yes. 2.4 multiplied by 0.95. Okay. This is the clockwise moment. Now, do we have an anti-clockwise one? Yes, we do. So that's just going to be 54 multiplied by pivot 0.45. That's it. Pretty easy question. Okay. I'll calculate what T is. I want you to read part 2 and see what the answer could be. 54. Okay. So T is supposed to be 33 newtons. 33 point. In fact, it's going to be 34 newtons roughly. Okay. Now, the string is cut so that the beam is no longer in equilibrium. Okay, we've covered this. Calculate the magnitude of the resultant moment about the pivot acting on the beam immediately after the string is cut. Now, it's a single mark question. It's very easy. If the string is cut, I told you, the string is the providing the clockwise moment to make sure that you stick to the ground. If you cut off the string, then that means the anti-clockwise moment is going to be much greater, right? If the bar is no longer in equilibrium, that must mean that the anti-clockwise moments are now too much compared to the clockwise moments. Okay, so that must mean anti-clockwise moments are now greater than the clockwise moment because the string was providing a clockwise moment. So how do you calculate the magnitude of the resultant moment? You basically take the difference of them, just like you do net force. So anti-clockwise moment minus clockwise moment. That's it. That's all you do. Okay. But in this case, you don't add in the clockwise moment of the string. So let's first check what were the anti-clockwise moment. The anti-clockwise moment was just, this one, because this was turning you anti-clockwise. And that means 54 into 0.45. 54 into 0.45 is the anti-clockwise moment minus what is the clockwise moment after the string has been cut? This was the only thing that was providing clockwise moment, right? So 2.4 multiplied by 0.95. 0.95. And that's it. That's the answer. Yes. I'll move on in a minute. Any questions? Hello, guys. Are you dead? 4 into 0.5. Wake up. It's Christmas. 22.02 anti-clockwise. This is the net moment. So, right? So the net moment is 22.02 Newton meter towards the anti-clockwise direction. Okay. And you will have to attach the string to make it balance out again. Okay. Sounds good. Yes, guys, any questions? Should I move on?
Yeah.
Yes, Aviya, Hania, all good?
Yes. Yeah.
Pretty basic stuff. Okay, sounds good. This is related to work power energy. We haven't done that yet. So we'll skip this. Okay, we'll skip this. We haven't done this as well. Again, related to upthrust. You get these kinds of questions, where only a certain portion of the ball is submerged. And then, you've got to calculate the upthrust, or you might have calculated the density of the ball or the volume. And that's where we've got to spend a little time on upthrust. Slightly complicated topic. Okay, this one. So, stereo is meant by the center of gravity of an object. This is their favorite question for movements. They always literally ask you this question. Okay. A uniform beam. What is the question? Wait. Okay. So, a uniform beam AB is attached by a frictionless hinge, okay, to a vertical wall at end A. The beam is held so that it is horizontal by metal wire CD. Okay. So, metal wire CD. Okay. The beam is of length 0.96 meters. Okay, that's useful information. 0.96 meters is the total length. The block of weight W rests on a beam at a distance of 0.2 from end B. Okay, end B. Okay, from here. The wire is attached to the beam at point D, at which is distance 0. Okay, blah, blah, blah. The wire exerts a force of 45 Newton at an angle of 37 degrees. Okay, so the wire is holding this beam with a force of 45 Newtons, okay, at an angle of 32 degrees. Okay. Calculate the vertical component of the force exerted by the wire on the beam. Okay, pretty simple. Vertical component is just going to be this value, right? It's going to be 45 sine what? It's going to be 45 sine 37, right? Because this is going to be 45 cos 37. 45 sine 37. Okay, whatever that is. By taking moments about A, calculate the weight W of the block. About A. Okay, so this is the pivot. Calculate the weight W of this block. Okay, now, how do we even solve this question? First of all, try to understand. Whenever you've got a moments question, always try to picture it and imagine that if you were to remove a certain weight, where would the bar turn? Always try to imagine that. Okay, so imagine that you have an empty bar right now. Okay, if you have an empty bar that is literally screwed to the wall from point A, this is the hinge. What do you think would happen? Would it stay flying there? No, because the bar is going to have a weight. It's probably going to pivot like this, right? Because it has a weight and there is going to be a moment about A, and because of its weight, it's going to turn clockwise. So I can straight up determine that the weight of the bar is going to provide a clockwise moment. Okay, now what next? Then I see that on that weight, I added another block which has a weight W, and that's also going to make my bar turn clockwise moment. Okay. Now, if there is nothing supporting the bar, then the bar is obviously going to turn in a clockwise direction, exactly like this. It's going to turn. What can I do to make it balanced? What can I attach to the bar to make it not fall down? I can attach it with a wire, exactly like kitchen. This is exactly like a kitchen cupboard or something like that. A kitchen, what do we call? Kitchen beam, right? Kitchen, hanging beam, yes. Kitchen hanging shelf. This is one of those hanging shelves which are, attached to the wall, but it is held down by some sort of wire. Okay. That means the wire is providing a clockwise moment. Sorry, anti-clockwise moment, right? Because it's going to, if you increase the force from the wire, right, then that means you are going to provide an anti-clockwise movement. If you pull from the wire too strongly, then the bar is going to go upwards. Okay. So if the bar is balanced out, then that must mean the clockwise moment and the anti-clockwise moments are balanced. Okay. So again, we're just applying the formula now. Anti-clockwise moment equals to clockwise moment. And thus, what are the clockwise moments? 23 multiplied by, this is tough. How do you figure out what this distance is? Oh no, wait, we do know that because this was the center of the mass, right? So if this is the center of the mass of a uniform beam, then that means the total length was what? The total length was 0.96 meters. So that means the point at which half of the weight is, the point at which the center of the weight is acting, it must be half the length, right? So 0.96 divided by 2 would be the point at which this is acting. So clockwise moment is equals to 23 multiplied by 0.96 divided by 2, right? Because this is the length from the pivot till the center of gravity. Plus, what was this? This is going to be W times 0.56 plus 0.20. So 0.76. So W times 0.76. Meters? Meters. Okay. And then anti-clockwise movement by the wire. 45 sine 37 into 0.56 as well. 45 45 sine 37 into 0.56. Okay, let's check it out. Let's check what the answer is. Okay, so 45 sine 37 into 0.56 minus 23 into okay, the weight is 5.43 newtons. This is the weight of W block. Okay. Next, the hinge exerts a force on the beam at end A. The hinge exerts a force on the beam at end A. Calculate the horizontal component of this force. The hinge exerts a force on the beam. So on the beam. So the hinge is exerting a force on the beam. Okay. How do you figure out what this is? Good question. Because we knew that this entire object is in equilibrium. We know that the clockwise moment, or net moment is zero. We know that net moment is zero. But we knew another thing as well. We knew that net forces are zero in all directions, right? In all directions. Okay, so that means, resultant force is zero no matter which direction you choose. Okay. Now, the hinge is in horizontal direction. The force by the hinge on the beam is horizontal. But if you remember, there was another horizontal force from the wire, right? Which was equals to what? This was equals to 45 cos 37, right? And if the beam is in equilibrium, then that must mean horizontally, F net horizontally is equals to zero, right? Then that must mean that the horizontal force by this hinge should be equal to the horizontal force by this wire, because there are no other horizontal forces that are acting, right? So this is supposed to be 45 cos 37. Okay, whatever that answer is. Yes. Does that make sense? Yes. Okay.
Yeah, it does.
Hmm. The block is now placed closer to point D on the beam. Point D. What is point D? Okay, so the block is brought over here, about over here. Okay, then what? State whether this change will increase, decrease, or have no effect on the tension in the wire. Hmm, good question. So moment is equals to force into distance, right? If you reduce the distance from the pivot, you're bringing it closer to the pivot, right? So that means the moment, in fact, specifically the clockwise moment is going to fall. If the clockwise moment is going to fall, then that means the if you want to make it in equilibrium, then the anti-clockwise moment should also fall, right? And if the anti-clockwise moment is falling and the distance of the wire is not changing, then that must mean the force of tension should also fall. Because think about it. If the tendency for the beam to turn is lesser, then the wire will have to provide less of a force to make sure that the bar is balanced, right? For example, if there was no block at all, if there was no block at all, then that means that the entire beam is not very heavy. That means that the wire won't need to have to provide a lot of force to make sure that the block, that the beam does not fall down. Okay. So that means it's going to decrease. Okay. The stress and when the wire, okay, we haven't done stress yet, so we'll do this later as well. Okay. Now this is a good question and we will only be able to do a little bit of it. Again, this is moments combined with upthrust. We try to do as much as we can. Just the first part is fine. State the principle of moments. Now, this means that the sum of clockwise moments, I am writing it down in short form, but make sure you write it down in a complete way. Use words, sum of anti-clockwise moments, okay, in an isolated system in equilibrium. Okay, so that's the principle of moments. Make sure you use exactly these words. There is no single extra word in this entire equation. Okay. A hollow plastic sphere is attached at one end of a bar. The sphere is partially submerged in the water and the bar is attached to a fixed vertical support. Okay. So basically, this is a fixed vertical support and this is the pivot. Okay. So that means this ball is connected to this, this bar, and this can either go up or this can go down, right? So this is a ball and okay, sounds good. So that means that the ball has a certain weight W. Okay. And because of that weight W, this entire pivot bends downwards. This bar bends downwards. For example, if you were to push the bar upwards, then what would happen is that the ball with the bar is going to come up. Okay. Let's see what they say now. The sphere has a weight of 0.3 newtons. The distance from P to the center of gravity of the sphere is 0.29 meters. Assume that the weight of the bar is negligible. Okay. Calculate the moment of the weight of the sphere about P. Okay, good question. Now, moment is just equals to force into distance, right? Force multiplied by distance from the pivot. Let's check. How do we do that? We know what the weight is, right? We know it's 0.3 Newton. What is the distance till the pivot? 0.29. Okay. Is that right? What do you think? Is this right or no? Any suggestions?
No,
No? What do we do then?
we'll have to first make it like a horizontal component, right?
Horizontal component or whatever component we need. Because if you remember,
So
moment is equals to force into distance. where they are both perpendicular. So if you take the distance as, for example, horizontal, then the force must be vertical. If you take the force as horizontal, then the distance must be, horizontal. So they just have to have a 90-degree angle between them. So yes, you were saying something.
I was saying that the will the angle that we need to take be 50 degrees?
50. Let's check. So let's see. I've made a simpler diagram. This is W, and this is going to be 40 degrees. Okay. First of all, if you're ever confused about what to do, right, we've got to simply figure out that if this is the distance that we've been given, right, you have to make sure that the force and distance are perpendicular. Right now, I see that the angle between my distance and the weight is more than, it's not 90, right? Because if it was 90, then it would be this force, right? Because I see that if this is the distance, then this must be the force that we need. Okay. So what do we do next? We can do two things. You can either calculate the horizontal distance, the perpendicular distance, or calculate the perpendicular force. Now, how do we do that? I can do two things over here. Okay. Yep, that's pretty simple. Now, if this is a triangle, right, we can say that this is a triangle. What if we were to calculate, sorry, if you're ever confused about the distance, always what you do is you extend the force, okay, in the exact direction where it is, okay, but you extend the pivot exactly in the same direction. So that means you draw another exactly same line in the direction of the pivot. Then that means the distance that you have to calculate is the distance in between both of these lines. Okay, that's it. So step one, just extend a random rough line in exactly the angle of the force that you have, and then extend another line exactly on the pivot with the same direction. Then the distance between these two lines is the distance that you have to take. Because if you check it out, if this is the force, okay, and this is the pivot, then isn't this distance exactly perpendicular to the force that you're taking? Exactly it is, because this is W and this is the 90-degree angle between the forces. Okay, so that means all you need to do is you need to figure out this distance. Now, isn't this just going to be 0.29 cos 40? And isn't this going to be 0.29 sine 40? Right? Because you have the hypotenuse, right? And if the in front of the angle is sine, with the angle is cos. So that's it. So that means the moment is going to be, it's going to be the weight multiplied by 0.29 cos 40. Okay. So that's it. That's how you figure it out. And the rest of the question is related to springs and upthrust and rest of the questions. And it's also related with energy. Oh my God, this is such a big question. Wow. Okay, a final boss question. Don't
How
worry,
many
we'll be
marks is
too.
that in total?
Uh, I don't know. It's not given. This
Mm.
is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. 13 marks. And they've pretty much included all of mechanics. So see, these questions are often linked. They've included vectors, moments, then this is related to deformation of solids, where you talk about springs and elasticity and spring constants. Then they've also brought in upthrust, right? And volume of the sphere submerged is blah blah blah. Okay. They've brought in upthrust, density, volume. They've also brought in elastic potential energy. Then they've include some conceptual question about upthrust and elastic potential energy connected. Okay, so that's why a lot of these questions are very, very linked. So here's another question. Here the question is related with a sphere that is submerged. So that means this sphere is going to have a certain weight W, and then because it's in water, it's going to have a certain upthrust force in the other direction as well. But it's also moving in a certain direction. So, there's a lot involved in this. Okay, sounds good. Don't worry, we'll do all of these and You will find it very satisfying. Okay. Yep, that's all for today. Any questions?